All right, so we're going to try and do something a little bit different this afternoon. I guess you could say this is how geeks have fun. We're going to pretend, we're going to have a little bit of a role play session here. And my friends Patrick and Paul are going to help out. We'll get to that in a second. I thought I'd start by kind of the standard polling the room thing. I don't think, so last year when I was here, and I talked about Ansible, I asked who has heard of Ansible, and it was sort of, 75% of the room. I'm not going to ask that question this time because I think everybody's heard of Ansible by now, right? But what I would like to ask is how many of you are actually using Ansible today actively? And this is going to kind of drive how many slides I put up on the stage. So if you don't want to see slides, okay. So that was kind of like maybe half the room, a little bit less actually using it. So what I'll do is talk a little bit about what Ansible is. And today, the focus for our session is really about how you can automate more and kind of a little bit about the reason why you want to automate more. I like these swim lanes because I think as we think about enterprise IT and where we are in sort of the transition and how we're moving to digital transformation and all those sorts of great things, it's really informative to kind of think about the different areas that are progressing forward and evolving inside of your environment. And I think early on in my career, I looked at a diagram like this and I always thought, well, I need to go as far right as possible, right? The newest, greatest, hottest technology, that's where I want to be. Well, the reality is in most of your environments and most of the customers that I talk to, you're going to end up with a variety of different applications and things happening inside your environment, right? You're not going to go, as much as we would love for you to go fully into OpenShift and invest in that hybrid cloud strategy. The reality is you're going to have end-tier applications that are running on virtualization platforms, and you're going to still have mainframes, some of you, and AS400s and all that sort of great stuff, right? So it's really important to think about automation in that context because you can look towards just automating the new hotness, but ultimately you have all this other stuff that you have to think about as well. And that's what we're really thinking about when we think about management and automation across the enterprise, and particularly with Ansible. So we have a few different products in portfolio. You're going to see most of these demonstrated today. Marcos and Ron talked about CloudForms a little bit earlier. We're going to mainly focus on Ansible right now, but Satellite is our product for actually managing RHEL environments. It does a whole lot of other things, but mainly it's focused on how do you do configuration management and patching for your RHEL environments. Ansible Tower is a nice way to wrap a UI and APIs around doing automation inside your environment and running playbooks inside your environment. And Insights is something that's relatively new. We introduced it, I guess, last year, I think it was. And now it has become kind of a platform for us that we're building more services on top of. But it's a way that we're going to take data, anonymized data from your infrastructure, and we're going to display patterns back to you or insights back to you about things that you can potentially be doing better inside your environment, if you're missing patches, if there are configuration management issues or configuration issues. And then the really powerful thing that you're going to see today is that we're actually going to present playbooks to you to say, okay, many customers that have this same, have a performance issue related to this configuration item, and we'll give you a playbook to actually fix that issue so that you can run it either against the single system that is maybe exhibiting the configuration issue or across your entire enterprise. It's a pretty powerful kind of combination. So when we talk about Ansible, we talk about Ansible as a language, first and foremost. So there's a YAML-based language that you're going to use to actually run automation inside of your environment. You're going to build playbooks in that YAML-based structure. And then Ansible Engine is the way that you're actually going to run those playbooks or run tasks inside of your environment. So one of the things that's new, I think that was just newly announced when we came together last year, I'm not sure how many of you were here last year, but Ansible used to be kind of just a project on its own. So if you wanted to use Ansible and run Ansible playbooks, and you just wanted to use the binary and run your playbooks and the modules that shipped with it, you didn't really have support per se. You kind of had best effort support from us. But now you can get support for Ansible Engine, which means if you just need to run automation, if you just want to build playbooks and automate some things inside your environment, but you don't need to share that automation across multiple teams, you don't need an API to access it, you don't need to aggregate the results of all of your automation in one place, then you can get support from us for Ansible. And that includes the modules that ship with it, as well as the binaries to actually run things, right? And then you get all of the good things that come along with the Red Hat entitlement, which includes open source indemnification, access to the documentation, et cetera, et cetera. All the good things that you're used to getting with Ansible. And then Ansible Tower, as I mentioned, is a way to kind of wrap a UI around it. Ansible is gaining incredible traction. Every time we put up this slide, the numbers are wrong. So I actually had to go to GitHub last night and update some of them. We have over 30,000 stars on GitHub, which is pretty crazy. There's a ton of modules out there. A subset of the modules that are the number that I'm listing here is actually ships with the product and is supported by us. And there's, this number is outdated too, but roughly 500,000 downloads a month, which is insane. It's one of the most popular automation products out there. And why is it so popular? Well, in my opinion, mainly it's because you have this human readable format to actually do automation. So it makes it very easy to define automation tasks, and it also makes it very easy to share those automation tasks with other groups so that your Windows team can automate in the same way as the Linux team, in the same way as the networking team, which is what we're going to talk about today. It gives you this ability now to define your infrastructure and your applications in a YAML-based text file, and then put that in some sort of version-controlled repository. So now that you have it in this version-controlled repository, your audit teams are happy, your operations teams hopefully are happy, because you know you're always deploying in the same way, because you can deploy your infrastructure based on this playbook that is inside of a version-controlled repository. So you always have this breadcrumb trail of exactly what you're deploying all the time. Our customers today that are using Ansible are using it to do a lot of different things. So yes, you can use it for straight up provisioning. You can use it for configuration management, deploying applications, continuous delivery. We have customers that are using it as part of their CD cycle. Once you add Tower to the mix, you've got an API to actually talk to actually deploy infrastructure automatically using whatever tooling you use today in your CI/CD pipelines. And you can talk to a myriad of different things inside of your environment. So I'm going to walk very quickly through how Ansible actually works, and then we're going to get into demos and the scenario that I described. So generally speaking, the users of Ansible are folks that are going to build the automation playbooks, right? And playbooks are written in YAML. And the great part about a playbook is that tasks are executed sequentially for the most part. There are some ways to kind of move things around. You can make more sophisticated playbooks, but generally speaking, you're going to build a text file that has tasks in sequential order. Really easy to read. You're going to use modules to actually talk to different components in your infrastructure. So the modules are actually the magic of Ansible that allow you to build these very simple command structures or these simple playbooks and talk to the different infrastructure. Essentially, a module gets copied over SSH to whatever the endpoint you're managing, and it executes code. That code gets executed, and the commands that you've actually put into your playbook are executed that way. I'm going to skip by plugins. Plugins are a way that you can extend Ansible. So if you find that your inventories aren't working the way you want, or there's additional capabilities you want to add to Ansible, the plugin architecture is a way to do that. When you build an inventory in Ansible, so you can build a text-based inventory that looks like this. It's an INI style file, and you're going to feed that into when you run the playbook, and you can run against these systems. So in this case, I've defined Web Server 1, Web Server 2. They're part of a group called Web, and I've got Database Server that's part of a group called Database. So now I can address each one of these systems individually when I run a playbook, or I can actually address the group and say, I'm going to run this playbook against Web, and it's going to actually run against all of the web servers in that list. The text style file, or the INI style text file as an inventory is great as a sort of a beginning, but if you have thousands of systems in your environment, like many of you do, that doesn't really scale well. You don't want to actually manage that in a text file. So we actually connect to a number of different inventory sources to build inventories from, say, your vCenter. We'll go talk to vCenter, we'll pull out the VMs, the list of VMs, and we can use that as an inventory. We can talk to OpenStack, we can talk to public cloud environments, and we can build your inventory dynamically based on the information we get from there to actually run playbooks against. And so there are modules out there that talk to, as I mentioned, a myriad of infrastructure. Here's just a sampling. I like to throw this up so that you can sort of look at it and say, okay, is that the technology that I use in my data center on this list? Yes, it is. If it's not on this list, then generally it's going to be in the modules documentation page. So it gives you a good way, a good sense of all of the things that Ansible can actually talk to. So you're going to get more information about Ansible playbooks. You're going to see some playbooks in action. You're going to see how that works in more detail. That's why I'm kind of skipping by that a little bit. Ansible Tower now provides this role-based access control and a nice UI to actually access and run this automation. Think about Ansible Tower as this top layer that's listed in this diagram, right? You're going to build your playbooks to do things inside of your infrastructure, inside of your enterprise, and then Ansible Tower provides role-based access control, a way to actually consolidate and aggregate all of the output from running of jobs, and also gives you an API to actually access running that. Ansible is also, Tower is also the place where you're going to build integrations. So if you want to talk to Splunk, if you want to actually have integration with a bunch of your cloud providers, you can do that directly with Tower. In additional, if you want to say talk to Slack, this is where you're going to do that and send notifications to whatever your notification platform of choice is. So from there, I'd like to introduce my two other amigos here who are going to assist with this. And as I mentioned, we're going to play some roles here. So Mr. Paul Armstrong, who you've already met, is going to play the role of a Linux admin, which is not a stretch for him because in his spare time he actually is a Linux admin. I'm going to reprise my role as a Windows admin. I started my career in Windows, and actually I was talking with a gentleman today who helped start my career and got pushed into Unix basically by a strong-headed project manager who said you should go do it, and that's how so I'm reprising my role as a Windows sysadmin. Mr. Patrick Toal, who you haven't met, is going to be a network admin. And so we're going to start by Paul showing us how he manages his Linux environment.
There we go. Can we hear me? Yep. Hi. So I am a Linux admin, and I spend the vast majority of my day looking at satellite, making sure that my systems are running. Oop, I'm going to have to switch it over. And this happens all the time too. So we go to our settings. Do it this way. So you can see, we can both see the same thing. We're going to mirror displays, say apply. And we should see keep changes. There we go. Very good. See everything up there? It's a little different down in there. That's okay. So I spend most of my days looking at satellite. I'm connected. You can see there's a little lock up in the very top right-hand corner. I'm connected into my lab back at my office. And typically what I'll do is, as I'm working, I will make sure that I'm authenticated to my environment. It's going to ask me for my password. And as a good sysadmin, I have a really long password that I frequently, yeah, right. I have a really long password that I frequently flub.
You left your Post-it notes at home.
Yeah, I did. Yeah, sorry. Anybody know my password? Okay, so I'm authenticated. No news is good news. And I can go to my satellite system and go to my lab and find my link to my satellite system. And lucky for me, I've got everything integrated so that I have Kerberos single sign-on in my lab. And so it recognizes me there, and I can see that there's a number of things that are going on in my lab. I've got a host configuration chart. I can see what the latest events are in my lab. But one of the things I want to take a look at is look at Red Hat Insights. And Red Hat Insights is, as Chris mentioned, it's a cloud solution. It runs as a SaaS offering in Red Hat's cloud. And what goes on is I register my systems, and the Insights agent collects anonymized data on the system, and then uses the information that we've gathered from all of our support cases, all of the work that people have done around building knowledge base articles, et cetera, and uses that to analyze what's going on in each of my systems. And then what it does is it downloads those recommendations to my satellite console. This is also integrated into a number of other products as well, including things like CloudForms. And so as I look at this, it's showing me the newest systems that I have and when they were registered. It shows me, oh, wow, there's a bunch of actions that need to go on here. Okay, well, let's go see what's going on. Let's click on this one. And it's showing me, oh, new Ansible engine packages are required. Okay, well, that's something, if we're doing Ansible demos, we better take care of. So there's 4 systems.
So Insights, sorry, Insights is automatically telling you any issue that's kind of happening inside your environment. In this case, it's telling you that you need to update Ansible engine.
Yes, it's telling me I need to do a variety of things. You can see on the list here, it's finding vulnerabilities that exist, the side channel attacks on modern microprocessors. I've got meltdown. 10 systems need meltdown patching. Oops. I should go and take a look at that. But it also gives configuration information, like decreased performance when I've got the different I/O processor or scheduler set up on my systems. And it will help identify each of these types of scenarios and give me the solution to fix it.
Wow.
So watch, if we go and I click on the 4 systems, it'll show me the 4 systems. And I can say, okay, let's select them all and create a new playbook. And let's call this Red Hat Day Demo. And I can say save. And it says it's created that inside my product. And now what I can do is I can download the playbook. Okay, cool. Let's throw this into here. Let's say save. Awesome. Let's go here and go CD desktop. Ansible. So LS. And where are we going? We're going to our
Capital A Ansible.
Capital. There we go. CD Ansible. Okay. And LS, we can see that our thing is there for Red Hat Day, and I can say Ansible dash playbook. And I can specify Red Hat demo.
So Insights identified issues inside your environment, told you how many systems had that issue, and automatically generated a playbook that you're now running against your environment to fix it.
Absolutely.
Wait a minute. That generated a playbook for your systems?
On the fly. Generated it on the fly and allowed me to download it immediately to my system and run it again, and now something went wrong.
Live demos.
Live demos. Gotta love live demos.
Yes. Question here.
So let's say if we're not going to apply this package for this server, after that, the user says, oh, you set the application that this is something wrong.
Sure.
When do we apply all that?
Yeah, so the question, if you couldn't hear, was, so it's great that I'm going to get this. If I run this inside my environment and something goes wrong, I get a call from a user afterwards that says, hey, my application isn't working, the database is not functioning, or something has gone wrong. What are my rollback options?
So variety of rollback options. I believe that there's a way to cause Ansible to back it out.
Yeah, you need to, this is kind of the first step in the journey, right? So you do need to apply kind of standard due diligence. I wouldn't recommend necessarily just doing what we did here, download the playbook, run it in your production environment. Probably not your best course of action, but it gets you started, right? And if you've done any work in Ansible, there's something that you need to automate. So you'll go and you'll usually go to the web, or go to galaxy.ansible.com. You'll find a role, you'll find a playbook someone's already developed, and then you kind of start from there. So really what we're trying to do here is not give you something that you're going to run directly in production. We're sort of saying that in this particular scenario, but you're not going to really do that in production. But you are going to take the playbook and use it as a starting point. It's your foundation. You go, okay, so here are the things I need to change. How am I going to do that inside my environment? If you're looking to do rollback, you're probably going to do some more advanced things. Maybe you might tag the tasks and then actually create another set of tasks that you're also going to tag for the rollback option. There's a few other ways you could think about that depending on what you're updating and what changes.
Yeah, and it really depends. For this one, it was fairly simple. It's enabling a particular repository. You can see that the repository wasn't actually available to the systems in satellite. So that's why we got a task failure. So that's something that we would uncover during our QA analysis. It might require additional changes in our environment, which we can add to those. We can add to those tasks, add to those playbooks. A simple thing from a YUM perspective, we can look at YUM history. We can look at a variety of ways to back that out. Or it's very simple. You look at the steps that the playbook has taken, and you orchestrate the reversal. One of the important things that I think that we failed to mention is a key notion of all the modules in Ansible is that they're something called idempotent. And that's one of the beauties, is if you take an Ansible playbook and you run it once and you get a particular result, when you run that playbook again, you get exactly the same result. And if you're using supported modules, they are designed specifically to do that. If you're building your own modules, and that's the code behind your Ansible playbook, those modules should be written in such a way that when they go and they execute and they'll look to see if the condition already exists. If it already exists, do nothing. If it goes through and performs a particular task, if it fails to do that task, it ensures it backs out all of those tasks so that the system configuration doesn't change. We're either changing the state completely or we're not changing the state at all. And that's the nature of Ansible being idempotent.
So pretty amazing demo.
I'm gonna
awesome.
Carry on.
Yeah, he's a Linux admin. He's got a busy day. He just fixed a ton of problems. Patrick, I don't know about you, but I have nothing like that in the Windows system, right? I've tried a bunch of different things. I got some PowerShell scripts. I've used CF Engine, and it's a mess. What do you have in the networking world?
What do I have in the networking world? Well, I have 30 years of history. Why don't I put this up here and we'll talk about that. All right, 20 years, but 30 years, we really haven't changed anything. Any of my network people in the room? Show of hands. People who have managed a network device? People who have seen a network device? Okay.
Yay, the people that keep our packets flowing, yeah.
All right. So you people will know that cutting and pasting templates is a pretty popular way of configuring your network devices. Ansible playbooks sound like a really, really good idea. We haven't changed this in the networking world in a long time, and part of the reason is because lots of people have tried to solve this problem for networking devices, and what we usually end up with is closed proprietary systems that manage one vendor's gear. They're adopted by one team in the organization, but not by the others. And we get into this scenario where it becomes shelfware, or it does a fraction of what it was promised it was going to do in the beginning. Ansible is none of those things. Ansible is open. Ansible is agnostic. Ansible is agentless, which means I don't need to install anything anywhere on my Linux host or on my network device. So Ansible is powerful because it doesn't care what it's talking to. We currently have, I think, over 40 different network vendor equipment types that we talk to. We have over 500 networking specific modules. So you can use a module to query information about interfaces or routing tables. You can run ad hoc commands, and we'll see some demo of that later. But the cool thing about Ansible is because it talks to everything, it talks to my Linux systems, and we'll see it talks to my Windows systems, and it talks to my network systems, is that I can build really complex chains of workflow. So I can build into my DevOps workflow actually provisioning some of the network stuff.
Wait, did you say networking and DevOps in the same phrase?
Is that not allowed?
That's amazing.
They're not going to throw me out, are they?
Tell us more.
Okay. So if we take Ansible, if we take automation and we add it to our networking, we're going to be able to save, first of all, a lot of time for our network operators. Anybody know what the acronym MOP means? MOP? Okay, it's not what we use to clean up when things don't go wrong, or things go wrong at 2 in the morning. Methods of procedure. So in the networking world, we create these long documents. Some architecture team goes and they write up, oh, this is what the network should look like, and then they throw it over a wall to an operations team. The operations team basically follows a script. Log into the router at 2 a.m., shut down these interfaces, install these upgrades, change these interfaces, bring it all back up, check to make sure it works. Oh, it didn't work, back it out, or fix it, or what have you. And they follow these big, long methods of procedure. And sometimes you do need a mop because they don't work and they create a huge mess, and that's why your internet doesn't work when you wake up the next morning. The idea of taking those mops, or even taking routine tasks that network operators do every day, like checking routing tables, making sure that interfaces are up, we can automate those now. And we can take some of that time back from those network operators. And what we're trying to do is apply the same kind of disciplines that are required for DevOps methodologies. To be successful, you need to standardize. You need to make sure that you have a process in place that is consistent and repeatable. And doing certain tasks by hand is always going to be error prone. But if you can define your infrastructure as code, whether it be software or networking hardware, you can now get repeatable, consistent, and less error-prone actions. So this is a journey. You're not going to get there overnight. Don't go and create your entire router and switch and data center configurations and then try and apply them, because, yeah, that will break. But you can start out very slow, and you can start to build little pieces of automation in the network on the router side or on the switch side, or even just provisioning VLANs, or even just checking something. You can just run the system in check mode, and you can find out things about your network without having to log in to routers manually and switches.
Wow, so
How about
that
a
sounds
demo?
like you're on your way to making the network as automated as what Paul is doing with his Linux systems.
Well, I'm on my way. I don't have insights for networking yet, which I'm a little jealous about, but
We'll
maybe
get there.
one day.
We'll get there.
Shall I jump into my demo, or do
Yeah,
you want
why
to talk
don't
about what you...
Why don't you show us?
All right, why don't we jump into the
what you're
demo?
up to?
So here's what I've got. You all still awake out there? Okay. I've got this tool called GNS3. It's basically a router emulator that does the same thing that we can do with virtual machines and Linux systems. So I've created a fairly simple topology here. I've got a gateway router on the top right. I've got a couple of core routers, and I've got a switch, and then I've got a bunch of stuff hung off of them there, just simulated systems. The entire thing is running in my lab, and if it all works well, I should be able to run an Ansible ad hoc command. This is just, there's no playbook here. This is just me running a command to trigger a module to make sure that I can reach all of my systems. This isn't a network ping. This is an Ansible ping, which means it's actually trying to log into the systems. So now I can see that I've got connectivity to everything. The first thing I'm going to do is I'm going to show you my playbook that I'm going to run here. So the first thing I want to do as a network operator is I want to make sure that before I change anything, I've got a backup of my configuration file. So here I've got a playbook. It's got 2 plays. I'm going to back up the iOS devices, and I'm going to back up the VIOS devices. VIOS is a virtual networking device, and I have no idea why my cursor is laggy, but I can show you this play here is going to work on the iOS devices, the Cisco routers, and it's going to back up the iOS config, and then the second play is going to do the same for the BIOS devices. Very simple playbook. And I'm going to run that. One, config backup. Ansible is now reaching out to my network devices. It's executing a task on each one. It's going to create a copy of it's going to create a backup of the configuration on each device. And I can go into my backups directory, and I can see them all here. So if I want to see the gateway configuration that I have, here it is. This is from my running router. By the way, there's 2 others in there. And if I had 100 routers, there'd be 100 files in there. All right? You can see that my system is not really configured much. I have my management Ethernet interface configured. I'm connecting to it via SSH. I have a default route. Nothing special. So now what do I want to do now? Well, let's take something a little bit more complicated. Maybe I want to configure the interfaces on this device. So I have 2 tasks here, again, 2 plays rather, with multiple tasks in each one. So the first play is for configuring interfaces on iOS. And my mouse keeps stopping. There we go. And task number 1 is configure iOS interfaces. And you can see I'm not going to go into the details, but you can get a general idea of what's going on here without knowing anything about writing an Ansible playbook. You can see that the task applies information to iOS interfaces, the name, the description, and sets the state. All right, I'm going to then apply this one. Something about this video connection has made my laptop unresponsive. Here we go, Ansible playbook 2. It's nice to have friends in the audience. All right, so I'm going to run this playbook now, and I'm going to configure the interfaces on my iOS devices. So while it's doing that, let me show you what it's going to do. In here, I have some variable files. Now, I'm using variable files, but you could pull this out of configuration databases. You could pull it out. I know some people still manage their IP addresses in Excel spreadsheets. I'm not judging. I'm just saying, we have better tools.
Maybe don't. Have you thought about not?
Have you thought about, yes. Okay, so I need to find my host variables, which are in here. And I'm just going to look at my variables for my gateway router, which are here. And you can see here I've got some very well formatted YAML files. And they basically just list out what I want my interfaces to look like. I need a loopback. I want it to be up. I have some fast Ethernets. I've described what they go to. I've got some IP addresses. Now, in the background, while I've been fighting with that, my playbook is running. And it's still running. When it's done, all of this information that's in these files will be applied. And so my topology here will actually have IP connectivity to all the links, whereas it didn't before. The links were connected, but there was no addressing, so they couldn't talk. Now, all of these addresses will be assigned, and I can actually run an ad hoc command between two of the devices. I won't do that because I'm fighting this machine here. I could run an ad hoc command and ping from one interface to the other. This is the other thing. I don't need to log into the router to go ping. I can type Ansible-M, and then I can do iOS command, and then I can run the command from there. And so I can ping from an interface to an interface on the other side. How am I doing for time? All right. So that playbook takes a long time because changing the state of interfaces in my lab seems to take a while. While that's running, let me show you the next playbook. So now I have basic IP connectivity. I'm going to configure my OSPF interfaces. I need some routing between the endpoints in my network. So I have a playbook which is going to configure OSPF. And again, one play, configure OSPF. It's going to run this on all of the hosts or network. So it's going to run it on all of my devices. And it's going to configure OSPF first on my BIOS devices, and also on my iOS devices. You see I've got a conditional here that says when Ansible Network OS is VIOS. So I know that the device is a VIOS because Ansible has gathered that as a fact. Okay? All right, so my first playbook is done. Now all of my network interfaces are configured. I can prove it. Password's Red Hat, by the way, in case anybody wants to hack into my network. So, show running config. All right, and so if I scroll down to my interfaces, you'll see that I've given my interface descriptions. Loopback is there. I have IP addressing, and that's done. So now I'm going to configure OSPF. I'm making a lot of changes to my network right now, but I don't have to. I can run a playbook against a router and just check stuff, which is probably how you would want to get started because you probably don't want to break stuff in the network. People get grouchy. All right, so for some reason, configuring OSPF happens like that in my lab. And I can actually execute an ad hoc command, which I will do here. OSPF. So this is an ad hoc command. Basically, what I'm doing here is I'm using the iOS command module to connect to my iOS routers to run show IP OSPF route. I only have one iOS router, but if I had multiple, it would do this on all of them. And in a moment, so now you can see that I have OSPF routes, I have the routing table, and I've gathered that as a fact. Now I can do some really cool things with that. I can then use that as input to some other process, trigger something else. Or I can do something simple like generate a report. So I've got 2 more demos, and I'll just show you the first one is a report that I'm going to generate based on information I collect. I didn't show you what this playbook is doing, so let me do that while we run it. So this is a playbook which is going to test various information. So it's going to check to make sure that the management interfaces are up. It's going to test the reachability to the management gateway on our iOS devices, and it's going to test reachability to the internet, and then it's going to test a bunch of other things. And then, at the end, it's going to generate a report. Now I'm using a templating language here. So I'm using a Jinja 2 template, and the Jinja 2 template is, seriously, does anybody know why my laptop keeps stopping responding? All right.
I can give you
I deserved that.
I can give you my Fedora laptop. I'm sure it'll work better.
Tough crowd. All right, so here's my template. So it's an HTML file. It's really simple. It's got some conditionals, some loops for hosts in play host. Yeah, I'm not going to bother doing that. So it's going to iterate through. And you can see here, this playbook is done running, and now I'm going to have a file in my report directory called generator report. So I'm going to open that, reports, generated report. And that should, hey, look at that. So here is the report that I generated. The interesting thing here is I've run a bunch of plays, I've collected data, and then I can verify, oh, my network interfaces are up. By the way, the EXOS switch I don't have enough functionality out of that module yet. It's still in development. But I can see here that the management interface is up on my 3 other routers, and I can see that there's internet connectivity from the gateway, apparently not from the other 2. And I also have reachability to the management gateway from all the hosts, which is good because otherwise my playbooks wouldn't run. And the last playbook I'm going to run is also a report generator. And this one is going to collect information about my network. And again, it is all device agnostic. This one is going to go out and collect facts from my routers because sometimes it becomes very difficult. We have a tool that collects stuff from Cisco, or we have a tool that collects stuff from a different domain. What if I want to know about my entire network? And so this last one is going to be sysinfo. Doesn't exist because I have 2 extensions. So here I've collected some interesting information. Again, my EXOS, I can't collect a lot of data from it yet. But here I've collected some basic stuff. You could collect a lot more. I've got the network host name. I've got the version of iOS running on my gateway. I have my serial number of my device. I have how much memory is in it and what model of router it is. So I have now just kind of scratched the surface of some of the things you can do with the networking modules in Ansible. But there's a whole lot more that you could do. I could configure access lists. I could respond to a security event, for example, and I could have my access list applied to my internet gateway to stop some vulnerability, or even dynamically creating access lists from inside my organization. If I have a service over here in this part of the network and it needs to reach a service in that part of the network, I can define in a YAML file what ports are needed to which IP addresses, and then that could be deployed to the network without having to do any manual changes, which I think would be really cool.
And so now that's all defined in playbooks that you can put in a content repository, you can version control.
I can check
it in.
it in.
Attached to your change management systems.
If you want to edit it, I can check it in, you can edit it. The other thing is, now that I have the ability to virtualize my network, now I can test some of this stuff. Complex routing changes, for example. This is stuff that we couldn't do even 5 or 10 years ago very effectively. So, yes, question?
Can you track configuration drift?
Configuration drift, absolutely. So depending on what parts of the configuration you want to track, for example, if I had a configuration template for my interfaces, I could tag certain interfaces as being access, for example, or certain interfaces being assigned to a particular business function. And then I could make sure, for example, that all of those interfaces had a particular access list assigned to them. And then if I run the playbook today, and it's not that way, it can change it. But if I run it again, I can run it and I can check to see, has this changed? And it will report, for example, I won't do it live, but so you have the choice, right? Ansible is very flexible. Sometimes you'll want to automatically repair something, but sometimes, especially with networking devices, one operator could log into it, make a change for something in a maintenance window. You don't want to back that out, right? So you want to check it, and then you can report on it. And you'll get, instead of saying OK, it will tell you that, so here it says changed 1, but if you run in check mode, it won't actually change it. So it will say change 1. You can go back and look and say, oh, that task, I got to go look into that router because that hasn't done, something has changed. That goes back to the idempotent thing that Paul spoke about earlier. If something has changed, we'll detect it. If it hasn't changed, that's when we get the OK1 and change 0. The network is OK. Nothing needs to be changed.
Sorry, I was thinking about the virtual network.
The question is there
okay.
do we treat physical networks or virtual networks different, or which one are we talking about?
So yes, so are we talking about virtual or physical networks? The answer is yes, right? Ansible doesn't distinguish between the two. If you want to run this on a virtual network, you sure can. There are, as I showed earlier, there are modules for lots of virtual networking appliances as well. You can run it on the virtual network to run tests, and then you can deploy them in production once you know that they work. It's scarily like DevOps, but don't tell that to the network guys. Sorry, did that answer your question?
Let's say if it's Cisco Router switch, do Cisco allow you guys to change the configuration?
Oh, so if it's a Cisco router switch, would this allow us to change the configuration? So Ansible is not using anything special here. The credentials that I'm using to log into these routers right now are just passwords. We're using SSH. But if you were running out of Tower, for example, you could assign credentials so that you could log into the router as whomever. There's no magic going on here. Underneath, the module is actually logging into the Cisco iOS VTY like you would do by hand. The difference is it's performing the tasks for you so that you don't have to do them yourself. So there's nothing magical about what Ansible is doing in terms of connection. We do support SSH. We do have some vendors are now supporting netconf as a way to interface with the devices. But we're not, this is agentless, so we're not requiring the network device to do anything special.
All right.
What is the purpose of doing this?
Well, so like much like automating the other parts of the environment, the real focus is to be able to say, I've got a simple automation language that kind of transcends all the DSLs that are out there today, and I can use that playbook across multiple places in the infrastructure. It's also human readable, and I can start to use it in something like Tower. We've got a few minutes left, and I'm starting to feel like a sysadmin again, and the network guy has taken over the meeting. So like lots of great information, amazing demo. I think if you have more questions about networking, Patrick is more than happy to talk about it, but
I'll be here.
I need to spend some time showing some love to Windows automation.
All right. I think we're sharing all these presentations later, so
Yeah,
I do have some resources that you can go and find out more, but I'll get out of the way so the Windows guy can turn.
So here's the question that I've been kind of dreading asking all day. How many Windows admins here? Hey, all right, okay, all right. It's not that bad then. Okay, we got a couple. I saw a couple hands. And if you were lying, that's okay. Thank you very much. All right. So I kind of figured as much, right? But what I really wanted to do today was show you, if I can find the USB port, is show you that there is an art of the possible here with Windows automation as well. So because there isn't a large population of Windows sysadmins here, which is not a super big surprise, given it's a Red Hat event, I'll skip through a good bunch of the information here, but I will show you some playbooks, and I'll kind of give you the highlights of what's interesting, right? So I'll skip through Patrick's section here. So first of all, Windows and Ansible. Red Hat is the Linux company, right? So why are we doing Ansible, or why are we doing Windows automation? Well, it's another thing inside of your infrastructure, and because Ansible is so extensible, it's just part of the possibility that you can start to use Ansible to manage Windows systems. And frankly, it started to kind of take on a thing of its own. The thing with Windows is today so Microsoft recently announced that they're going to join the rest of us in kind of the 21st century and have SSH bundled with their operating system. But before now, it really wasn't an option. So most of the plugins, or the modules, that are built for Ansible and managing Windows are built to use PowerShell. They're built in PowerShell, and they use WinRM. It's a different connection plugin. We can get into the details of how you actually do that, but essentially in your playbook or in your Tower configuration, you need to tell Ansible, okay, don't use SSH, you're going to use WinRM. That does mean that you need to do a couple of things in your Windows system. I guess I should be focusing on the two people that said they're Windows sysadmins. But it means you do have to do a little bit of magic behind the scenes to make sure WinRM remoting is actually turned on, and the ports that are available, all that sort of good stuff, right? Every modern version of Windows has PowerShell 3 and up kind of on it. And any version of Windows, most versions of Windows, you can install PowerShell 3 or above. And that's all Ansible needs to kind of manage that. In addition, there is a WinDSC module. So if you're managing your Windows systems, you can actually use a PowerShell DSC, the desired state configuration, and Ansible together to do a bunch of interesting things as well. What follows is a list of modules to allow you to do some interesting things. And given the time, I'll skip through a bunch of these, but suffice to say, we support Chocolatey is a module that's out there today, and that works great. You're going to see a playbook that does that. You can use WinPackage as well. Reboots, favorite topic of Windows sysadmins, right? I'm not going to make a joke about Windows reboots except to make a joke about Windows reboots. You got to reboot Windows systems, right? It's a fact of life. And so we've done a bunch of work on the Windows reboot module and the update modules to make it so that it's easy for you to tell Ansible, hey, you should probably reboot after this, or do things like, hey, I'm going to run some updates. Register the results from the Win Update module, and you'll see more of the Win Update module in a second. And then just check and run that reboot when you actually need to. So if the update result actually includes, yeah, reboot is required. If this condition is true in the when statement, then I'm actually going to do the reboot.
So can you use Ansible to reboot it at the least opportune moment for what I'm doing?
Yes, absolutely.
Okay.
Yes.
Check.
Right in the middle of whatever it is. Yes. Absolutely.
Preparing my demo.
Yeah. The Win Updates module has some really interesting features. So what you see here is Win Updates listed at the top. This is kind of an abbreviated form of a playbook, right? I'm losing a lot of the verbosity that you would typically see in a playbook to make it a little more readable, but I'm using the Win Updates module. In category names, I can actually say critical updates, security updates, feature updates, application. There's a whole list of different types of updates I can add in here. I can say reboot yes, which means once the Win Update module has finished its work, this task is completed, then yes, the system is going to reboot. And I can also blacklist knowledge base articles. So for folks here that are Windows sysadmins, there's always at least one knowledge base article that conflicts with a storage driver or something. I see the nods over there. So you often want to be able to blacklist some of those. That's super important. IIS configuration, everybody's favorite topic. I guarantee you in your enterprise, you still have IIS-based applications that have a .NET middle tier and have a SQL backend, and there will continue to be developers that do that. So configuring IIS is something that we'll continue to do. It's really easy inside of Ansible, right? It takes a lot of the, if you're hunting and pecking through the UI to try and figure out now where have they hidden all these features to actually turn this stuff on, forget about it. Just use an Ansible playbook, and there's an example here of how that works. Editing registries are now possible, so I can actually change values of specific keys, and I can actually bulk import, and that looks kind of like this. So I can use WinRegEdit and say, here's the particular value I need to change, or a particular key I need to change, what value I need to insert, or I might already have a registry entry that I've built out, and I just want to import it in bulk. I can do that with WinRegMerge. And then services. So Linux folks using Ansible have enjoyed this capability for a while to really manage your services through Ansible. You can do that with Windows now. You can list dependencies. You can make dependencies start when they need to. You can define the startup mode. You can even use pause if the service actually supports it, and define what usernames to start as. Just an example here. Again, I'm going to keep kind of sprinting through this. Managing domains is kind of a big deal, especially in test environments where you're likely to start using Ansible, and the ability to actually create a domain, join a domain, promote domain controllers, demote domain controllers, and manage users. It's a great thing to be able to make that super simple to actually do inside of a test environment. And it looks like this, right? It's really easy, it's human readable. Even if you're a Linux admin, you can see what's happening here, right? You understand that we're creating some domains, we're managing some users, right? ACKS are a little bit different in Windows, so we've got to be careful how you actually manage ACKS. There's an inheritance model. You need to propagate in certain ways. You actually have a ton of rights that you can allow and deny. It's pretty granular, and it can get a little bit crazy. But we've built a module to deal with that as well, so you can actually manage the inheritance model. You can set ACKS at a top level and actually recurse. And man, the amount of time that I've spent looking at the Explorer UI, waiting for that bar to crawl across the screen to apply stuff like that, is done now, right? Just run the Ansible playbook and wait for the results. So I'm going to show you very quickly a playbook that I've made up, hopefully. So what Paul was up to was pretty cool, but mostly operational tasks, right? And what I want to do on the Windows side is I need to be able to get to because Linux, let's face it, is the new hotness, and everybody's excited about Linux. So I want to actually make Windows a little sexier now, and I want to go back to the business and be able to show them that we can deploy Windows very quickly. We can deploy applications very quickly. And so one of the things I want to be able to do is on my systems, I want to be able to deploy tools that I use every day on my Windows servers super fast, right? And I can use Chocolatey to do that. I don't know if you're using Chocolatey in your environment today. Great package manager, came out a little while ago. It lets you do things that we've been doing in Linux for a very long time, right? From a command line, just install some packages, point to a repo, and you're done. In this case, this particular playbook is actually just going to install procxp, which is an explorer for processes, lets you see a lot of details about what the process is actually running. And I'm going to actually install Git because how do you have a server without Git these days, right? In this case, I'm actually going to run this playbook against a Windows VM that I have running in Azure. And as you can see, I've been troubleshooting my playbooks all day, just to make sure everything is cool. So I've shown you the playbook. I'm just going to run Ansible playbook. I'm putting an I to point to an inventory that I have here. And we are going to run the, oh gosh, install tools YAML file. And if it's going to go. In this case, so the beautiful thing about these Windows modules, so we built them to be idempotent like the rest of the modules. So in this case, because I've already tested this a couple of times, Chocolatey is already installed. If this was running against a Windows system where Chocolatey wasn't installed, that's the first thing it would do. This particular module will check. If Chocolatey is not installed, it's going to go grab it. Obviously, all your standard kind of caveats apply there in terms of network access and where you're going to get it from and all that sort of good stuff. But it's a great way to show, to very quickly install some things. So that's running. You can see I'm installing the tools. So those are operational tools I need for my Windows servers. The other thing I'm going to do is show, as I mentioned, I want to be able to show that we can deploy some things quicker. And so this particular playbook is going to actually, is going to create a new website. It's going to create a new web app in IAS. So I'm talking to the Windows host here. I'm going to say gather facts because for demo purposes, gather facts just kind of slows things down a little bit. And the tasks I have here, I'm going to create a directory first. So this playbook actually creates the directory, sites. And then I'm going to go get some awesome web content. Now this is actually just a GitHub repository that has an index HTML. That's pretty simple. But I wanted to show, I need to show to the business that, hey, I can go out, I can grab code from the web, I can put it into a file, put it into a directory, and then I'm going to make sure that IIS is installed and configured. I'm going to create a new website, and that's it, right? So pretty simple, but a quick way to actually deploy this stuff. And my Git deployment is still waiting, but.
While you're waiting for that,
Yes, sir.
you know what would be really cool?
What would be really cool?
Is if you, why do you say it like that? Is if you could deploy your web server, and then you could call my playbook, and then I could make sure that the network ports were open for you, and then add you to the firewall load balancer. That would be really cool.
All possible.
Yeah, absolutely.
Now, if we put our playbooks in Tower, we could actually share them around, and we could do that sort of interaction.
Yes. And then we could also have a workflow that if something went wrong, we could have a backup playbook.
That sounds pretty awesome.
I think we need to do that.
Yeah. So my playbook is running long. We had a long conversation. It is currently 1:44. So I'm going to keep this going here, but I'm going to guess that we're just about to wrap up and go to a break, I think, at 1:45. But I did want to thank you all for your time. I want to thank you for being a Red Hat customer. Obviously, we can't do what we do if you don't do what you do. Thank you to Paul Armstrong for being a part of this. Great demo. Thank you.
Thank you, Paul.
And thank you, Patrick. I'm going to run this playbook. I'll be still standing up here. If you have any questions, commentary, concerns, please feel free to come up and say hi. But thank you so much for your time.